Okay, so today is polynomial functions. The quiz scores are in. I'm going to try to have your homework scores in by maybe Tuesday. I'll try to give them back to you next week. Maybe I'll give you your graded quizzes tomorrow. So, polynomial functions. So we kind of already discussed what a polynomial means. So poly means many, and nomial means numbers. So many numbers, many terms. So a polynomial expression in a single variable are in standard form when the degrees of the variable are written in descending order. So what this means is if you have something like x squared plus x plus 3, this is in standard form. The exponents are in descending order. It goes 2, then 1, and then 0. Now, this is in standard form because it's all in a single variable. If I had x squared plus y plus 3, that's not a single variable. We have more than one variable. And if I instead had x squared plus x to the 4th plus 3, that's not in standard form because they have to be in descending order. Okay, the coefficients of the first term is called the leading coefficient. So let me rewrite this so it's in actual standard form. X, let's have like 3x plus 3x squared plus 2x plus 3. Okay, so this is in standard form. It's going from biggest exponent to smallest. And then the coefficient of the first term is called the leading coefficient. So the first term is my x squared. This 3 is the leading coefficient. Have we discussed this before? No, in Algebra 1, did you guys do this? Maybe not? Okay. The degree of the polynomial is the greatest degree of its terms. So what is the degree of this polynomial I wrote? 2, right? Because which term is the biggest with the biggest exponent? The x squared. So the degree is the highest exponent. All right, so these are all polynomials. The first is a constant because it has no x in it. So technically the degree is 0 because this is 12x to the 0. But remember, x to the 0, anything to the 0 is 1. 4x minus 9 is linear. So this is, I think chapter 2, we covered linear equations. Right, the degree is 1 because that's the exponent for the highest, for the term with the highest exponent. The degree is the highest exponent. Let's go to the quadratic is squared, cubic is to the 3rd power. So notice that this is in standard form. Highest exponent 3, and then 2, and then x to the 1st power, and then no x. The coefficient, leading coefficient here is x because it's the number in front of the variable with the highest exponent. Okay, so I'm just going to call a couple people and you can tell me what the degree and the leading coefficient are. Let's start on the side. Felix, do you have a question? Mm-hmm. Okay, do you have a pencil?
No.
Okay, do you want to borrow one from someone?
Yeah.
Kind. All right, let's start with Jesse. It's all right. We got this, right? We got this. It's be a good day. We're going to learn a lot of stuff. You guys will be successful. So, ready, Jesse? I'm going to have you do the first one for me. State the degree, leading coefficient, polynomial, blah, blah, blah. First, what is my leading term, right? What's my leading term? Do you know the leading term?
Yeah.
Which one is it? 5, x to the 6th power. So, the leading coefficient is going to be 5. Felix, what is the degree of this polynomial here in A? What's the degree?
6.
Exactly. It's the exponent of, it's literally the highest exponent.
It doesn't matter that it's not in standard form.
It is in standard form. X to the 6, then 4, then 3, then none. It goes highest exponent.
You don't have to do
smallest.
like a placeholder thing?
No, because we're not dividing it. I'm just like looking at it and saying, which is my highest exponent?
Okay.
And then whichever term has the highest exponent, the number in front of the variable, that's your leading term. Okay, this next one's a little more tricky. I'll just keep going across. Jordan, what is the degree of B? And like, how do you find it?
5? Foil.
Yeah, we got to FOIL first, because I don't know. We got to FOIL this out. So if I FOIL first, 6, outer, plus 4x, inner, minus 15x, and last, minus 10x squared. First, outer, inner, last. So let me just simplify this a little bit. So I have 6 minus 11x minus 10 squared. Kaylin, is this in, oh, no Kobe. Okay. Okay, so I'll go to Caitlin. Caitlin, is this in standard form, the one I just wrote? It's not. It's not in standard form, not at all. Noah, do you know which the Will you tell me which term is the leading term? The one that matters.
Negative 10x.
Yeah, this is going to be the leading term because it's the term with the highest exponent. All right, Cooper, what is the degree here?
2.
2. And then let's go to Caden. What is the leading coefficient?
10.
Negative 10. Right? Because it's a minus 10. It has a negative 10 front. Because if I would rearrange this, if I put this in standard form, I'll have negative 10x squared minus 11x plus 6. The negative like stays in front here. All right. Do you feel like you could do this if I gave you another problem?
Yeah.
Bomb.com. Awesome. Okay. That's good. It's not at all. I probably should stop saying that. I wasn't like even, I don't know, I was like a baby when that was like popular. It's like the 90s.
People said that.
Yeah, in the 90s. Oh my god, it's so bomb.com. All right, let's try the next one. Function format. So this isn't really new. I believe we went over this in chapter 1, maybe like section 2 or something. Way beginning. So we want to find f of 3b if f of x equals this equation. All this means is everywhere you see an x, you're plugging in 3b. That's all it means. So f of 3b is equal to, okay, everywhere you see an x, plug in 3b. Everywhere you see an x, plug in 3b. Now that I did that, I just have to simplify. And lucky for you, the first section of chapter 5, we learned about exponents. So if I have 3b squared, this is going to be 9b squared minus 6b plus 5. Okay, so if I have 3b being squared, it's the same thing as 3b times 3b. So that'll just be 9b squared. Or you can think of it this way. Ready? Take this square, distribute it out. So I have 3 squared times b squared. Okay, so that's really all we're trying to find is put it in function format. So this is what f of 3b equals to. What?
Why
No,
60?
it's
6b.
Oh, I'm sorry.
You know, yeah, these actually look, semi-different. Some people's 6s are the exact same as their b's. That was shown on the quiz. But if it's, if you wrote it after the a, I assumed it was b, and if you wrote it before all the variables, I assumed it was 6. Okay, do you feel confident to try the next one?
Yes.
On your own? No? Okay, that's also cool.
Bomb.com.
I'll give you like 10 seconds. Just try to like write the first line. So you see how I when I put in the 3b in for my x, like this line, I just want you to do the first line. We can simplify together, but I want you to try the first line. Find 2 there. Right? Is that what's missing?
No, it's 3x that's in parentheses. If you put the whole
Oops.
thing in parentheses.
That?
Yeah.
Okay. Did I mean to change this one? Possibly. Let me look at the practice test. I thought I went through and made things a little better. Okay. I'm going to changing it. Yeah. This is a problem. This is an example problem that Algebra 2 does. But instead what I'm going to do is f of x minus 1. So it's a little easier, right? It's a little easier. So what you have to do is everywhere you see an x, you put in x minus 1. Okay, everywhere you see an x, we're going to put in an x minus 1. So this is 2 times x minus 1 squared minus, and then you have to put in x minus 1 squared, x minus 1. Okay, so notice I put in parentheses. Parentheses are your best friend because they will save you from missing lots and lots of points. You have to use parentheses. That way you do the correct order of operations. So the first term is 2 times x minus 1 squared. So x minus 1 is being squared. And this is still something we struggle with doing. X minus 1 squared is the same thing as x minus 1 times x minus 1. To solve it, you must FOIL. You must FOIL it. You have a binomial squared, you got to FOIL it. Okay, if I say it one more time, you think you'll get it? Foil! You have a binomial, squared. Got a foil. Okay. X squared minus x plus 1. So I end up with 2 times x squared minus 2x plus 1. So that's this first part. And then what about this negative right here? Who do I leave off on? Jacob, what do I need to do with this negative right here? Distribute. I must distribute it to both of these. That's why it's important to have parentheses. Because this makes it plus 1. Unfortunately, on the final, there was a question similar to this, and we forgot to distribute. So this makes it negative x plus 1. This is what you'll mess up. You'll have a minus 1 instead of a plus 1. Okay, and then I just have the plus 1 here. Notice I kept parentheses around this part that's in blue because I'm supposed to be multiplying everything by 2. So I'll give you a couple seconds. I want to make sure you understand the order we're going through. But done, what's the next thing I should do? I have to the 2. Distribute the 2, right? Distribute the 2. Okay. Distribute, distribute, distribute. So I have 2x squared minus 4x plus 2 minus x plus 1 plus 1. Simplify what? Oh, I guess I could have done that with this. Yeah. Okay, ready, Adi? I gotta think which game show this is. Like fill in the blank. The next thing we need to do is blank, like blank. Combine, like terms. Combine like terms. Okay.
Bomb.com.
Bomb.com.
I'm sure there's actually .com for this.
Oh, I'm sure.
Like I feel like if I look it up.
You're such the bomb.com. Yeah. Okay. I'm sure that's like what it is. Whatever. Okay. So we must combine like terms. Combine like terms. So I have 2x squared minus 5x plus 4. Yeah? What? Combine like terms.
No, do you not? I love math.
What are you doing? What are you doing? We're doing good, right? We're doing good. We just like keep it together. So today, after we're done with this lesson, I have a practice worksheet we're gonna work on together that may or may not have problems you'll see in the future. Okay,
I
cool.
love worksheets.
They will be very helpful. It will be helpful. It's good. It will be helpful. Okay, ready? Let's keep going.
That was cute.
All right.
Do we actually have to like graph at any point?
I'm sorry, what?
Are we gonna have to graph it all?
For what?
This chapter?
For it's a graph and that messes me up.
Didn't I give you a practice test?
I'll tell you right
I'm
now.
talking about in this 5
I
point.
did. I did give you a practice test.
I didn't look at
I mean, ish. I mean, you have to like, sketch a little bit. All right, graphs of polynomial functions. So you already know these graphs. Remember that? Yes. Well, that's why I wrote it. Because this is what the answer is.
So if I just had two, like
I mean, if that's what you wrote, that would be fine.
okay,
Yeah. But also, low key trying to prepare you for the next year where that is what you have to have. Okay. Yes.
Really quick question. For homework, are we gonna need to use graph paper for this, or would you
I don't think there's any
like real
graphing.
graph? Okay.
No. So that's exactly what Jesse just asked me. All right, ready? Graphs of polynomial functions. So we kind of already did this graph dance for a while. If I have a graph, ready for this one? Y equals 2.
Yes.
Y equals 2 is a flat line. Flat line. Come on, Felix, what are you doing? Yep, power. Let's go. Okay, ready? What does y equals x look like? Y equals x. It's a line. Jordan, turn around. Ready? We're focusing. We're going over these graphs. We've done these graphs before. What about y equals negative 2? It's a little lower. Okay. Y equals negative x. Right? It has negative slope. How about y equals x squared? Parabola? Yes, question?
What?
What? You have to go bathroom? I didn't even hear it, but that's what I assumed. So you said, okay. Yeah. Okay. Wait, Jordan. Okay, that'll be your fourth, just so you know.
Give me a card. I don't have no money.
Okay, ready? We are going. Focus. Focus, focus, focus. Focus. You know these graphs already. What does x equals 1?
Oh, wait. No.
X equals 1. Vertical. It's a vertical line. X equals 1 is a vertical line.
Wait, what?
X equals 1 is a vertical line. Stop talking. Okay. I'm going to give you 3, 2, 1. Please stop talking. I'm trying to make this like kinesthetic learning, right? Movement. Instead of me standing up here droning on about these graphs, you know what it means. Kine means movement. If you look up the prefix kine, it means movement.
Kinetic energy.
Yeah, energy that moves. So, ready? What does absolute value of x look like? It's a V. It's a V shape. Parabola, ready? X squared. U shape. Y equals x is a line. Okay, what we're going over is on the board. A constant function has a degree 0. So, okay, I'm over it. I've asked you to be quiet. I've asked you. So if you keep talking, I'm marking you down. I'm marking you down. I've asked you nicely. I've tried to be calm about it. I don't like being petty and marking you off, but we gotta get through this, okay? I want you to get through this worksheet so that way on the next quiz you can get 100.
Are each quiz going to be
So,
5 questions?
No, it's much longer.
Is it like all?
Okay, I'm not gonna talk about the next quiz today. I will talk about it tomorrow. I want to get through this lesson. So, if you have a constant function degree 0, this is something like y equals 5. It's a flat line. That's what I had you guys do. Y equals 2. In the words of Cooper, it's a T-pose. A linear function is degree 1. So this is like y equals x. Maybe y equals x plus 5. This is just a line. It's chapter 2. Right? You have it in slope-intercept form. Degree 2. This is like something x squared, right? So maybe this is negative x squared plus 5. And it's negative in front of x squared because it's facing down. So those are the 3 we've gone through in depth already last semester. The next one's called a cubic function, right? And if you have a Rubik's cube or something that's a cube, it's literally 3 dimensions, right? A square is 2. A cube has 3 dimensions. Well, guess what? A cubic function is to the 3rd power. There you go. There you know. So an example of this is, I don't know, x to the 3rd something something, whatever. Look at the 4th degree. The 5th degree, right? You just add another Humpty Dumpty every time, right? So squared, and then cubed has another, and then to the 4th is another even whatever, hill. You're adding a hill every time. Adding a hill every time.
So if it was like...
I wish I answered this question already.
56, there would be 56 hills.
It's okay. It just, I know it shouldn't be, I'm a teacher, it shouldn't be a pet peeve when I have to repeat things a 5th time, but it is. We don't have to, I don't think I assigned you graphing something like this. What you do have to do is talk about the end behavior, like what's happening at the ends of our graphs, right? So if I have x squared, ready? What does x squared look like? It's a U shape. It's a parabola. It's a U. Ready? So I should see everyone with the U. Ready? X squared. Okay, I need your fingers to be up so you can literally look at your hands. X squared. Okay, what is happening? Can you point to your fingers? Ready? Just have your fingers. They both are going up. What about x, y equals x? It goes like this. One is going up, the other is going down. What about cubic function? Look at the ends. What's happening?
Up and down.
Up and down, opposite directions. How about x to the 4th degree? They're both going up. They're going the same direction. If you have, okay, so let's talk about a pattern emerging. So we've graphed some things with our arms. We're talking about the end behaviors. So if something has an even degree versus an odd degree, so an even largest exponent versus an odd largest exponent. So if you have an even degree, what's happening at the ends?
They're both pointing up.
Both ends point in the same direction. Yeah. So for instance, what?
Even what?
Even degree. Even degree. So notice, to the fourth power, they are both pointing in the same direction. They're pointing up. Ooh, when I had a negative x squared, even though it's pointing down, they both are pointing down. So for even degree polynomials, the ends face the same way. It just depends if you have a negative in front of, a negative as your coefficient or not. So if you have an even degree, the ends point in same direction. All right, another thing that we can say is we're symmetric at the y-axis. What does the word symmetric mean? I think I meant Carly. What does it mean when something has symmetry? Something symmetric. Right? They always say like the most beautiful people in the world have a symmetric face. Even, right? Like the left side is the same as the right side. Right? Have you ever like accidentally, I don't know, wrote a birthday card for someone in pen and then you like closed the card and then you opened it and it accidentally put ink on the other side as well?
No.
Yeah. Maybe that's relatable, maybe not. Literally, the left side and the right side are the exact same thing. That's what it means to be symmetric. So, I'll say it's symmetric. Symmetry across y-axis. And then the third thing is like they always have the largest exponent is an even exponent. That's what it means to be even degree, is the largest exponent is even. Okay, and this is in comparison to odd, right? If I have something to the third power, something to the fifth power, what's happening to the ends? Point different direction. One always goes up, one always goes down.
So if it's even then, it's in
Exactly. Look at this pattern emerging. Beautiful. Yes.
Can I stop now?
Yeah.
What if even a negative could be an exponent?
All the negative does flips it. Ready? Look at the right. It's facing down. So
so
if you have
it's the
x
same rule.
squared versus like negative 2x squared, flips it down.
It's the same rule.
Yeah. So if you have x cubed, looks like this. If you have negative x cubed, it just flips it. Yeah. Okay. So odd degree. Have you guys learned this before? Maybe not. Yeah. Okay. Hopefully it makes a little more sense. We're gonna have more practice with it. So odd degree. One end goes up, other goes down. All right, the second thing that we can see is it's symmetric around the origin. Okay, what that means is if you take your paper, ready? Watch this. You take your paper and you rotate it upside down. It's the exact same graph. Okay, ready? Take your paper, rotate it to upside down, and it'll be the same graph. That's what it means to be symmetric around the origin. You take your head and you stand on it, and then it's the exact same graph. You just rotate it 180 degrees, exact same graph. Symmetry across the origin. All right, so if we take this cube function and I rotate it 180 degrees, ready? I'm going to move it over here. I will rotate it 180 degrees. Oh, it's the exact same function. Interesting. And then third thing, well, I mean, it's an odd degree. What that means is it has an odd exponent as the largest exponent. An odd number, 1, 3, 5, 7, 9, 11. And then the bottom half of this page is just going a little more depth into this. I think it literally answers the question Jesse asked. What if we have a negative in front of it? Well, we're going to discuss it. So even versus odd degree functions. So there's 12 questions total for this assignment, and 3 of them are SAT prep. So not too bad. Some of them will go very fast because remember the leading term and like, right, the degree, those questions are pretty fast. Okay, do we need more time to write this down? Okay. What? So, okay, I hear you. but it's it looks harder than what it is.
Is LC leading coefficient?
Leading coefficient. Hey. LC, leading coefficient. Even odd is talking about the exponent. So, for instance, if you have a even degree and you have a positive leading coefficient, do we know what it looks like?
Yeah.
So you just roughly have to sketch this, right? This is what it looks like. If you have an even degree, so that's a even exponent. So example is going to be 3, maybe y equals 3x squared. Right? Both ends go up.
So if it's a negative, then it goes down.
Yeah. So I'm going to point that out for you one more time. So positive leading coefficient, right? Positive leading coefficient, positive number in front of the variable. Even degree means an even exponent. Cool. So imagine if we have a, let's go down here, an even degree. So if I keep this the same, right, it's x squared, but a negative leading coefficient, the negative in front causes it to reflect down. Oops. Do that. Okay, so, right, I have, looks like this, so maybe this is something like y equals negative 3x squared. Both ends go down. I mean, I could switch it a little bit. Maybe make this to 6. No, I'll leave it squared. So, negative leading coefficient just means a negative in front of your variable. Okay. We ready for the next? Cool. All right. All right, if I have an odd degree. So remember, degree is just talking about the biggest exponent of your polynomial. So the biggest exponent is odd. That means 3, 5, 7, 9, right? An odd number. And what we know is the ends are going to go opposite direction. So, but if you have a leading coefficient that's positive, right? So a positive number in front, like 2. And then I have an odd exponent like 5. Think about this. We got to think which way it goes. So remember, we know they're going to go in opposite directions. But which way is it? Is it this way? Or is it this way? We got to think.
First way.
So if I pick like a positive number, what is a positive number to the 5th power? Positive or negative? Positive times itself 5 times? It'll be positive. And if I take a negative times itself 5 times, 3 times, right? Negative times a negative times a negative. Here, I need your finger. Here, stand up. Yeah, there you go. I'm gonna have you do it like this. Ready? Negative times negative times negative. Ooh, 2 negatives, make a positive, and I'm left with 1 negative. Hey, turn around so they can see.
Oh, I'm sorry.
Yeah? Yeah? You guys see? Are you ready? Okay, ready? Negative times a negative times a negative. And if you take 2 negatives, that turns positive, you're left with negative. Okay. I don't want you to mess this up. I'm just trying to make this as straightforward as possible. Okay, so we know it comes down like this. Wonderful. What happens? What happens if you then put a negative coefficient in front of it? Like negative 2x to the 5th. What's going to happen to this? But what's going to happen? It's going to flip. Hey, flip it. Okay. So then it will look something like that. So notice, if you have a positive coefficient and an odd degree, it goes up on the right and down on left. Versus if you have a negative coefficient, it's going to go down when you're on the right. And up on left. Okay. We're good? Maybe give you another 10 seconds or so to draw this, write it. I feel like it's helpful if we color code like this. So the last thing we have to talk about is end behavior. So the end behavior, we don't care about what's happening in the middle, just the ends, right, where our arrows are pointing. So the blue on the left, the even degree, they're always going the same direction. They both are either going to positive infinity, or they both will be going down and going to negative infinity. Versus an odd, they're going opposite directions. So one will be going to positive infinity, and the other will be going to negative. Yeah. So this is normally something that, I don't know, I think the students last year did fine with it. So this part of your test is like, should be straightforward. I give you a graph, you tell me the end behavior. I literally have it graphed for you. So you know if it's going up like this, they're both going positive. If it's going down, they're both going to negative infinity. If they're going opposite ways, you just have to decide, okay, which one is positive, which is negative. Do we need more time to write this? Okay. So I'll maybe leave it like that. All right, so end behavior. Have you guys heard of infinity before?
Yeah.
Yeah, what context?
Never ending.
To infinity and beyond. Yeah. I taught that.
Infinity.
I taught that to my nephew. So secretly, I was trying to like teach him things that annoy my sister. So he's almost 3 years old. So he has this little Buzz Lightyear toy. So I taught him to say to infinity and beyond. And so that's all he did for like a whole day. That's all he said. He would just run up and say that to her, and she was really annoyed. Yeah, it's great. Okay. Infinity and beyond. So what that means is like infinity goes on forever, right? It's not actual like number you can pin down, right? It's like, oh, if I have a number line, like here's 5, here's 0. Infinity is not actually on there. It just goes on forever. What's wrong?
Nothing, I'm just confused about this.
Infinity? Welcome. It is. Well, I'm trying to reduce the confusion. So if you feel confusion, just let me stop. Let me stop and I'll explain it. All right, so are you ready for this one? The domain of polynomials are all real numbers. The domain of all polynomials are all real numbers. So if I ask for the domain, I'm going to give you a graph of polynomial, and when I ask for the domain, it's going to be all real numbers. Did I just tell you an answer for the test?
You did.
Yeah, probably. The end behavior of the graph of the function behavior of the, oh my god. The end behavior of the graph of the function behavior of the functions. What? What did I write? Of the graph of the function behavior, okay.
Is today the 16th?
Of the function as x, oh my gosh. Oh my gosh, oh my gosh. This is crazy.
Wait, there's a quiz on.
Matty, come look at this. Look at this. It's like buzzing out. Do you see it? It's going like this? Yeah, what the heck? Okay. Ready? Let's keep going. My eyes hurt really bad. This is crazy. Okay. The end behavior of the graph of the function as x approaches infinity, large or small numbers, x goes to infinity or x goes to negative infinity. One. Please stop talking. Please stop talking. Your guys' quiz is the 21st, which is Tuesday. It's no, not saying test. It's a quiz over 5.3 and 5.6. Correct, on 5.1 and 5.2.
On what day? Tuesday, Monday?
Tuesday. We don't have school Monday. On the 21st. But it's actually going to be very doable. Wink, wink. If we can get through this, we can go over part of the practice problems. Yes, the quiz will be fine. The quiz will be fine. It's, you should get a good grade on it. We'll put it that way. So, there's a reason to give you a practice quiz. You'll be fine. Just be here that day. Be here that day. Okay, end behavior. Either you're approaching as x goes to positive infinity. Which way is positive? Left or right?
Oh, I'm gonna have to say right.
Right. So, as x approaches positive infinity, all this means is as we go to the right. As x goes to negative infinity, which way is negative infinity? Which way is negative?
The other
Left.
way.
So, as my graph goes to the left. Okay, so ready? As x goes to negative infinity, let me read this. As the function, as x goes to negative infinity, the function goes to infinity. This is, we are on the top of the third page, whatever it is. So this is how we write it. I'm going to do the example and then we'll go on to the study guide. Okay, example 3. Consider the function below. Is the function odd or even? Okay, so is this odd or
I'm
even?
gonna have to say that's even.
Okay, ready? On count of 3. Think about it. Think about it.
That's odd, yeah.
1, 2, 3.
Odd.
Odd. How do you know? Felix, how do you know?
Because the arrows are going in different directions.
Exactly. They're going different directions. See, you're good. B. What is the degree? Do we know the degree?
I say it's
Well, okay. Jordan, turn around. What are we doing?
sorry.
Okay. So, the degree. We look at how many times it's turning.
It is
It's 2.
How many times are we turning?
I have to say 2.
2. And the degree is always one more than the number of turning points. Maybe you don't know that. But this is a cubic function. Because, ready? Squared has one U shape. Cubic, ready? You have to add another U. And that's roughly what it looks like. On the test or quiz or whatever it is, like I forgot to write the equation here. I'll give you the equation, okay? I'll give you the equation. It's all good. Okay, how many real zeros are there? So wait, what does it mean by 0? 0 is another word for, Natalie, do you know?
No. Intercept.
The x-intercept. Oh my gosh. So, remember, real zeros, this is just talking about the x-intercepts. So think about how many x-intercepts we have. How many do we have? 1. We have 1 x-intercept, so therefore we have 1 real zero. Right? Oh, you see how this thing's turning? You know, if it's not real, it's got to be imaginary. So that is where the imaginary roots come from. That's why I have to teach you imaginary in chapter 4.
Are they coming back?
Mhm.
Oh god.
Hey. Yeah, okay. Yeah. Okay.
That's not bumping.
Estimate any real zeros. So, okay, what number is this
One.
about? Where is this? Maybe negative 2.3? Right? The real zeros at negative 2.3 or so. Right? We're counting the x going to the left. It's about at negative 2.3, comma 0. And then the big kahuna, end behavior. Yeah, this is the one. Hopefully you can tell what I'm focusing on. Think about things I'm caring about. Degree, leading coefficient, end behavior. Ah, okay. I don't know, I'm just trying to be like as crystal clear as possible. Okay, end behavior.
I'm gonna have to give that a 0.
So, hold on, let's think about this. Okay, so this is how you write it. As x, and then you draw an arrow, infinity. What this means, as x goes to infinity. Ready? As x goes to the right. As we go to the right, I want to know what's happening to my function. Is it going to positive infinity or is it going to negative?
That's
Ruby,
the first
what do you
time I've ever
think?
drawn an infinity.
Hey. So, as x goes to infinity, as we go to the right, what's happening to my function?
It's going up.
Yeah, to up. It's going up, so therefore it's going to pause infinity.
How do you draw
So-
infinity? Can you like give us
How we write this? Okay.
I don't want to turn my paper.
F of x goes to
I was
positive infinity.
I'm actually hella gassed at drawing an infinity. So
no. Okay, do you know how to draw an 8 like this?
Yeah.
Just do it on the side.
Yeah.
Or 2 circles like this.
Oh, I did it. Let's go, baby.
Yeah, dude, look at how sick this one is.
You can do like this, like that.
Jeez, language bug.
I do like this, like that.
Hold on.
Okay.
Yeah. Okay, so what this means, as we go to the right, y is going up. Shh, stop. Okay. Okay. This is gonna be a rough participation week.
yes, it will.
Man, this is gonna be a rough week. 4 different people. Okay. Who have constantly been talking today. All right. So this is the left end or the right end. Which way do we go here? Which way do we go?
Right.
To the right.
To the right. This is the right. right? So this is where we're going to the right. As x goes to positive infinity, as we go to the right, we see that the y is going up. So we say it's going to positive infinity. As x is going to the right, approaching infinity, y is going up, approaching infinity. Now we're going to do the other side. All right, Dylan, you're up. So I'm going to write it this way. As x goes to negative infinity, I would like to know what's happening with my y values, my function, right? So as we go to the left, what's happening to my y, Dylan?
It's going down.
It's going down. So we say it's going to negative infinity. That's it. This is the end behavior. Right. Either it's going up or it's going to go down. I'm not going to trick you by having it flatten out and go to 0. No, that's next year's class. Right now, I'm only going to have you going to those two. So what I'd like to do is go through as many of these as possible. So when you get this, try out number 1 and 2. Try out number 1 and 2 when you get this. This is down.
Dude, like, the eye guy.
No way. That was the stupidest fucking thing. That was so stupid.
Okay. So it is the 16th. So I want you to try number 1 and 2. Try number 1 and 2, and we're going to go through it. But I want you to try it first. Number 1 and 2. What I just handed out.
Wait, one? That's not possible.
So, state the degree and leading coefficient of each polynomial in one variable. If it's not a polynomial in one variable, explain why. So, this one, I want to know the leading coefficient, and I want to know the degree.
The leading coefficient would be like 1.
1.
The leading coefficient is 1. What's the degree?
A.
1. The degree is the exponent. Do we have an exponent of 1? Ah. What?
Because
It's like
A is the variable. A is the variable.
So why isn't it A?
because A is
A is the variable. Degree is the
Whichever
exponent.
one has the most A's is
What?
the LC.
Wait.
So, leading coefficient is the number in front of A, which is a 1. The degree is the exponent, which is 1. Okay. Let's try number 2. Oh my gosh, we have to FOIL it out. Oh my gosh, we have to FOIL it out. First, outer, inner, and then last. This is definitely the term we care about because it has the highest exponent. I mean, you both are being marked off participation. So, like, I didn't say you. I didn't look at you in the eye. I was looking at Jordan Dunn in the eye. Just like, if you don't interact, if he's the one being shenanigans.
Yeah.
He is the one who's turning around. I keep that in mind. Okay, this is the term we care about, 8x cubed, because it has the largest exponent. The leading coefficient is 8. The degree is 3. Cool? Let's do... So I'm going to skip around a little bit. Let's do like number 9 and 10. Do we have questions about these? I feel like for the most part, you guys get leading coefficient degree. Leading coefficient is just the number in front of the variable, right? Which variable? Oh, the one with the highest exponent. And the degree is just whatever the highest exponent is. So as long as you find the right term, you're locked in on the right numbers. Okay, so we're going to try number 9 and 10. You know what? I'm only going to do one of them. Let's just do number 9. I just want to do an example of each of what we've done today. Let's do number 9. So, I'm trying to find p of -1 and p of -2. So this is just pure function notation. So you're just plugging this in. Yep. -1 and 2. So there's 2 different ones we have to do. So this is just function notation. We're just plugging straight in. Direct substitution is what it's called. Direct. So everywhere you see an x, you will plug in a -1. for the first example, and then everywhere you see an x, you'll plug in a 2 for the second one. So I'll give you about 10 or 15 more seconds to try out the rest of this before I continue. But I want you to try it. Felix, are you done?
No, guys.
Wait, why are we plugging these numbers in?
It's okay, I'm just trying to have it zoomed in so people can read what I'm doing. So, the quiz that's on Tuesday is very doable. I just look at these problems, change them a little bit, and I just selected a couple of them. So it's pretty straightforward. Yep. Okay. Continue. Okay, so hopefully that's enough time to try it out. So 2, negative 1 squared is 1, plus 4 plus 1, 7. And then if I try the other one, 2 times 4 minus 8 plus 1, the answer is 1. Alright, do we feel confident in these so far?
Yeah.
Okay, that's good, that's good. I want you to be as confident going into this quiz as, well, I hope you were the last one, yeah?
What does the f of x stuff really have to do with the graphing?
So eventually what we're going to do is plug in a whole function inside of another function. It's called a composition. Yeah. I mean, I don't know if that actually answered your question or not. But I decided not to skip over some of this, even though, we did function notation before. Just make sure we're all groovy with it. I want to do 17. Maybe 17 and 18. Those would be nice ones, because I think this is what we struggle with a little bit. 17 and 18. Is this the back page? Yeah. Okay, let's do 17. So, p of a squared. So notice up above we have 2 equations we can plug into. One is p of x, the other is r of x. And since 17 is p of a squared, we're plugging into the p of x equation.
So do you need it?
So, everywhere, so let me just write what p of x was. P of x is 4x squared minus 3. Everywhere you see an x, you're plugging in an a squared. So, p of a squared, I think you have the right idea, is 4 times a squared squared minus 3. Ooh, we got a power of power. All right, so I think it was Jesse. What do you do? What do you do? Is that what you said?
I had a question about that.
Yeah, what'd you say?
8 to the power 4?
Yeah.
Okay.
Because an exponent to an exponent you multiply. So this is just 4a to the 4th minus 3. Hey, okay. That's doable. Yeah, we're doing 18. I just want to make sure I'm not rushing you too much so you can write it, think about it, understand when you have a power to a power, you got to multiply those exponents. We're going to do number 18. We'll do number 19 and 20 as well, and that's where we'll stop. So 18, r of x plus 2. So we're plugging this in place ever there was an x in my r of x function. Okay, so r of x was 1 plus 3x. So that means is we're plugging this in place of x. I think I actually got there, everyone, today. So the 3, what do I really need to do with this 3? I must distribute. That was the trick play of this one. You had to distribute. 1 plus 3x plus 3 gives me an answer of 3x plus 7. It's 4.
It's 6.
Oh, yeah, I did the math right. I just didn't write the 6. Okay. Is this, we're good with these two? Yeah? Okay. So, if you're confident, like you could do these by yourself, you should feel good. You should feel good. You got the gist of today. We're going to do number 19. So, for each graph, describe the end behavior. Determine if it's, what?
I said that would be nice.
Oh, sorry. So 19, describe the end behavior. See if it's odd or even, and state the number of real zeros. So first, let's do the end behavior.
It's negative infinity.
So as x goes to positive infinity, so this is going to the right, what is happening with my function?
It goes.
It's going up, yeah, so it's going to positive infinity. How about as, let's do the left end behavior.
Wait, do you write right or up?
What? I'm not writing either one. This is the answer. But I'm writing the word right just so you understand, because I assume this is the first time you've ever done end behavior. So I'm trying to like solidify in your brain for you.
Did that say F of X?
And then the left end behavior, as x goes to negative infinity, f of x goes to negative infinity. So we know this is an odd function because they're going in opposite directions. And then there's only one real zero. There's only one place where it crosses the x-axis. So this isn't homework. This is just, I wanted more practice to go over stuff today. Okay, so we'll end there. That way you can pack up and then leave at 2:20.
Thank you.
But I'll see you guys tomorrow. Tomorrow we're going to cover 5.6. I'll see you guys.
Thank you.
Yeah, we're going to cut all that out. 5.6 is about 2 pages of work, and then we can go over questions.
Mr. Brian.